Hi everyone, in the previous video we talked about how we can generate the electrophile. In this case our electrophile is Br+, alright, and we have completed step 1. Alright, so there are also many other ways that you can generate other electrophiles. There are ways you can actually use the acid-base reaction to generate your NO2+, which is another electrophile. Alright, so in this step, in step 2, our job is to finally form the carbocation ion. So first and foremost, we have to look at our reactant here. Alright, so in the following video about directing groups, you will know that it will be directed to either this position or this position here. Alright, so we just need to choose one of them for our for this explanation. If you're unsure about how you can how this directing effect works, you can refer to the other video on directing effects. Alright, so let's get down to drawing this mechanism. So this is my benzene ring. Alright, so just take note that in this circle here it is just alternating pi bonds. Alright, so in the structure, this is the calculate structure of a benzene ring. So what you're actually using is this double bond as your electron source. Right, so what we are going to do is we are going to put our electrophile here. So this is our electrophile and this is our nucleophile. So we'll draw an arrow out from here to Br+. Alright, and what we will have is, so we draw this whole thing first. Alright, NO2. Okay, so now we are going to add our Br to this position. Alright, and this becomes a carbocation ion. So can you see that? So now the carbocation ion is represented by this positive charge in the center, and if you see this curve here, alright, this smiley face, it has to point towards these two groups, because all these groups here, they are all these carbons are sp2 hybridized, whereas this blue carbon here is sp3 hybridized. Alright, so at this point in time the aromaticity is destroyed, so that is why it wants to regenerate its aromaticity, it needs to remove one of these atoms attached to it.